Imagine standing in ancient Egypt. There are no cranes, no bulldozers, no heavy lift helicopters. Yet, sitting right in front of you is a solid block of granite weighing 50 tons. The Great Pyramid of Giza contains roughly 2.3 million of these blocks, stacked hundreds of feet into the sky. Seeing people climbing over the individual stones provides the only real way to grasp the sheer physical mass of the structure. Because modern construction relies entirely on combustion engines and hydraulics, the human brain tends to short-circuit when looking at this scale. This gap in our understanding is exactly where myths of lost technology or outside help begin to take root. Every block represents a specific negotiation with the laws of physics, utilizing a toolkit of simple mechanical advantages to move massive weight. To see how they achieved this, we have to look past the finished monument and track the physical journey of a single stone from the earth to the sky. The journey for the heaviest granite blocks began in the quarries of Aswan, located hundreds of kilometers south of the construction site. Freeing a 50-ton block from the earth created the first logistical bottleneck, cutting through granite without the existence of steel tools. Workers used pounding tools made from dolerite, a rock even harder than granite. By repeatedly striking the rock surface, they painstakingly bashed out channels into the bedrock to isolate the block. The extraction phase relied on a system of thousands of small, repeated actions, not extraordinary individual strength. Once freed, the stones were loaded onto flat wooden sledges. Without the wheel, Egyptians had to drag these multi-ton loads directly across the desert floor. This chart shows the physics problem of dragging a sledge on dry sand. The runners push the sand into a mound, and as that mound grows, the force required to pull the sledge increases exponentially. Wetting the sand in front of the sledge runners changes the environment. A precise amount of water binds the grains together, creating a rigid surface that allows the sledge to glide with significantly less resistance. This specific detail appears in ancient artwork, a worker standing at the front of a sledge, pouring liquid directly onto the path of the runners. Dragging a sledge works for short distances, but moving 50-ton blocks hundreds of kilometers to Giza is a massive waste of energy. Egyptians utilized the Nile River as a natural highway, loading stones onto barges to weaponize buoyancy. Using the river transformed the journey from a terrestrial nightmare of friction into a cargo and flotation problem, allowing the water to carry the bulk of the weight. At the Giza construction site, the workers face the final bottleneck, getting these blocks hundreds of feet into the air. This wireframe demonstrates the use of massive ramp systems. Whether they were straight, zigzagged, or wrapped around the interior, these ramps allowed teams to pull sledges gradually upward. For precise placement, they used levers. By tilting one side of a block, inserting a support, and repeating the process, they used incremental lifting to move massive weights using relatively small forces. With ramps and levers, a block's total weight never had to be lifted all at once. The Egyptians defeated gravity by dividing a colossal load into manageable forces: a sledge, wet sand, a barge, a ramp, and a lever. Individually, these are primitive tools. Their functionality depended on the height of systems engineering, an invisible web of human organization that synchronized thousands of workers across generations. Archaeological evidence from worker settlements at Giza shows a highly organized, fed, and medically cared for labor force, moving away from the myth of unorganized slave armies. This project required the simultaneous coordination of surveying, tool maintenance, boat transport, and food logistics on a scale that few modern projects ever reach. The Great Pyramid remains a massive 4,500-year-old demonstration of what happens when simple tools are scaled through relentless, synchronized logistics.